Welcome back. We're ready to start Lesson 2. If you had any questions or remaining concerns over Section 1.1, please do not hesitate to go ahead and ask those and get those clear. As you all know by now, math is such a building science, it's such a building mathematics that if you get behind at one point, you're even further behind if you don't see to it when you get to the next chapter. So please don't let any questions or concerns ever build up in any math class, and more specifically for us in this math class. Section 1.2 is about linear measure. We're going to talk about a couple of things here. First of all, we want to put the definition of a line segment into the context of what we talked about in Lesson 1. We talked about a line being an infinite set of points that extends in opposite directions, like so. And we talked about the different ways to name that line. But since we can't draw a complete line, because it's infinite, of course, most of the time we take pieces of the line that we talk about, and we identify and work with that certain set of points. Now, this is called a line segment. A line segment is a piece of a line. And we name the line segment by its two endpoints and a segment symbol on top. If I want to know the measure of that segment, I take the little hat off and I just put AB. AB with no sign on top of it means I want to know the measure from A to B. It may be in metrics, it may be in inches, it may just be in units. But we need to always remember the difference in these two, because when I'm asking a question on a test or a quiz, that will be significant. And you don't ask hints and questions on a quiz or a test anymore. You've outgrown that luxury. All right, now also just remember that I can name this like a line. I can name the letters in the opposite order, and that still indicates that I'm talking about the piece of the line between A and B, like I've just squiggled in there. All right? I always find it interesting every year to go over this with students. I want to make sure you understand the concept of measuring inches. And I know you were probably thinking, of course I understand that, but I want to just bear with me and let's see if I can make myself a little bit clearer. When I have a measuring line, a yardstick or a ruler, and I want to measure something with that particular measuring tool, the one thing I want to start off doing is make sure that wherever the tool is marked as 0, that is where I put my item that's to be measured. Okay, so don't always assume that the end of your yardstick or the end of your ruler is to go down at the end of your object, because as you see, you would lose some accuracy in there. Always make sure that you put the 0 of the measuring device at the end of the item you're measuring. And yes, sometimes that will be the end of your device, but it won't always be. So check out your measuring tool first and make sure. Then we want to look at, and I'm just going to mark out 2 extremely large units here. Okay, I'm going to look at how to tell the fractional part of a measure. I'm surprised every year about how many kids really don't understand that piece. So let's make sure we understand that. Okay, when I put a little hash mark right there, notice that if I want to know how many units that is, I count how many pieces I have between 0 and 1. I've got 2 pieces, so that's going to make this denominator 2. And I'm coming over one of those 2 pieces. Therefore, from 0 to this dot is 1/2. Okay, when I come over here to 1, you see I've gone 2 of the 2 pieces. And what is 2 over 2? Well, nothing but 1/2. Nothing but 1. So I've got 1/2, 1, then I have 1.5, and 2. But let's look if we tear or we break our little unit into more pieces. Let's say we break it up like so. Now count how many spaces you have between one full unit. You have 1, 2, 3, 4 spaces. Therefore, this particular measuring device is marked off into fourths. So I have 1/4, 2/4, which we already know is 1/2 of the way, 3/4, and 4/4, which we know again is 1. Okay, again, we found out that was marked in fourths because we look at the number of spaces between each unit. Now, if I go and break this up further, let's say I cut all of these in half. Count your spaces. 1, 2, 3, 4, 5, 6, 7, 8. So this particular tool would be divided up into eighths. So I have 1/8, 2/8, which if you remember a while ago was 1/4, 3/8, 4/8, which is what? 1/2, 5/8, 6/8, which a while ago, remember, was 3/4. And then this was 7/8. And then, of course, 8/8 is again 1. Excuse me. So when my measure is in eighths, this is how I would measure an item with the tool. Now let's go a little bit further. Bear with my eraser. I don't want to erase anything important. Okay. Now what if I go in and I mark all those in half? Then when I count the spaces between each little piece, I have 16 spaces in between each hash. So that particular tool would be divided off into 16ths. If I went and divided those into half, I would have 30 seconds. Usually in our room, we will measure in 16ths or eighths, but you always want to be as accurate as possible. So again, to find out how your ruler is divided up, count the spaces between one full unit and the next full unit. The spaces will give you your denominator. It will tell you, is this particular ruler divided up into fourths, into eighths, into 16ths, or to 32nds? So the denominator comes from counting the spaces. But the numerator comes from counting the marks, the hash marks. Okay? So if you count over to this particular place, that is, we've got divided up into 16ths now. So that's 1, 2, 3, 4, 5, 16ths. So if I measured something this length, that would be 5/16 of an inch. Okay, they talk a little bit about measuring, but I think that we've had enough discussion on that for now. We want to discuss another concept called betweenness. Betweenness of points. All right, for betweenness of points to exist, you have to look at the segment that you are answering the question about and see if the points that you have been asked to determine if you have betweenness for, if the points are collinear. I hope you remember from the last lesson that means that the 3 points are on the same line. So if I look at this example here, I cannot say that P is between N and B because P is not on the line with N and B. I can say that B is between N and R because B is on the line or collinear with N and R. So the first thing when you're dealing with betweenness is you have to observe collinearity. Now once you have observed collinearity, then there's a little formula that's very easy to remember, and we'll use this as our model. From one end point to the point that you're trying to show is between, plus that point again to the other end point, has to equal the full measure of from end point to end point. So the distance, notice I don't have the symbol on top. See that, with that symbol being gone, that means distance. So the distance from P to M plus the distance from M to Q must equal the distance from P to Q. So if we'll look at their example down here below, assume that the figure is not drawn to scale, and guys, you might as well get ready for that. Not most, but a lot of our drawings are not going to be drawn to scale because the book and your teacher want you to be able to back up your measures and your answers, not because of the way something looks, but you want to back it up based on mathematical evidence, correct mathematical fact, to be able to say if something is true or not. So just go ahead and get out of the habit now of assuming that something's going to be drawn to scale, because a lot of the time it's not. Don't let that throw you. Now, in example 3, if I'm trying to show that F is between E and G, first of all, I observe that I do have collinearity. F is on the same line with E and G. So since it is, to show betweenness, I have to show that from E to F, which is 2 3/4, plus from F to G, which is 2 3/4, has to equal to the entire distance from E to G. Okay, and I'll leave the arithmetic for us to think about. Okay, now let's look at 3. Example 3. We're supposed to find the entire length of GL. Assume it's not going to scale, and we've got to use the concept of betweenness. K is between J and L. Now again, do not fall into the trap of thinking between means halfway between. Okay? That does not necessarily mean halfway between. When we do have something halfway between, we'll call it a bisector, and that'll be another day. But for right now, if a point's between two endpoints, we will know that from J to K plus from K to L will equal what they've asked us to find, which is JL. So the 8.4 plus the 3.9 has to be my JL measure. So when I add those two together, I get about 12.3. That's the length of JL. Okay? Now, a lot of students I've had in the past, in their homework, a lot of time when they show their work, and you will always show your work, okay? That's just a given. Always show your work in math with a pencil, not a pen, but with a pencil. I've had many students to start this habit, which I like very much. They like to highlight their answer. Okay? So on the paper, it's easy to see exactly what they intended for the answer. Now, that's not something I'm going to make you do, but it's kind of neat to make sure you always identify for your teacher what you meant your answer to be. Okay, there's some more examples here you can follow through. I want to look at example 5 first. Give me some scrap paper down here area to work. All right. All right, find the value of A and XY. Again, notice that XY does not have a bar over it, so that means find the measure of XY. If Y is between X and Z, XY is 3A units, XZ is 5A minus 4 units, and YZ is 14. So now we're going to use the concept of betweenness, or two parts make the whole. So as I add these together, I'm going to have that my 3A plus 14 has to equal to the entire length of 5A minus 4. Now I'm just going to use algebra to solve this. I'm going to subtract 3A from each side. I'm going to add 4 to each side. Then I'll divide each side by 2. A is 9. Okay, now let's answer the question, because the question sometimes that's asked in geometry is not just find X or find A. You've got to make sure you've answered the question. And this says find the value of A and XY. So go back and see what XY is. XY we're given is 3A. So we have to plug in the 9. So XY is 27 units. Okay? All right. Congruent segments. Congruency. Congruent means same shape and same size. So congruent items are going to have the same measure. Their measures are going to be equal. As I look at in the key concept box I have, congruent segments have the same measure. Do you see these little hash marks? We will use these all year long when we draw drawings to indicate that that gives us a little visual that from A to B is the same length as from C to D. That gives us a really good visual to be able to look at a drawing even when they get more complicated, or I should say especially when they get more complicated, so that we can at a visual glance tell what's equal to what. So by knowing that A and B, or AB rather, is congruent to CD, and look at that symbol. Segment AB, it's the equal sign with the little tilde. My two segments are congruent. I would say then their measures, see there's no symbol on top, their measures are equal. But if these guys are congruent, then I'm going to be able to set, I had to erase that so I could see my drawings. I can see that my 1.7 centimeters in AB equals the 1 centimeters in CD. Do you remember when something's equal to itself, what algebraic property that is? That algebraic property is your reflexive property when you've got identicals on each side. We will start the year in the fall, making sure we have those properties down pat. I see one up here I could have expanded on a little bit. Right in here I could have said 9 equals A, and then when I flipped that around to A equals 9, that's your symmetric property. I hope you remember those. If not, we will have a chance to review those very shortly. All right, as we look at some of these exercises, I am fond of 5 and 6 right now. Find the measurement of each segment. Assume that each figure is not drawn to scale. So as I look at 5, if I want to find CD, I'm not happy that they put the bar on top. I wish they had put it this way. Okay? But if we want to find the length of CD, we just have to add the distance from C to E and E to D, and we're going to have a 3.8 units as our answer. But on one like 6, they give us the total, and we have to find RS. So if I find RS, this time I have to do a little subtracting, not very difficult. There's my whole segment of RT. I'm going to subtract out the part that is ST, and I'm going to have 2.4 centimeters for the length of RS. Okay, that should be pretty basic to you. Hope it is. All right, let's look at some of these. I am feeling some factoring coming pretty soon. And I like to give you problems that you have to factor because I like to remind you of those concepts. Let's look at that some here in this section. Let's look at a few examples here. Find the value of the variable and the length of yz if y is between x and z. Now, I draw almost all of my figures that go with these problems. It's just I'm very visual. You're going to learn that throughout the year. And I'm going to draw these because I think drawing them gives us a much easier sense of what we're dealing with. So I've got y between x, z. And I am not going to worry at all about this being on scale. I've got y between x, z, and that just gives me something I can refer to. Now let's look at 21. XY has a length of 11. YZ has a length of 4C. And then from X to Z, you have a length of 83. Again, we're supposed to find the variable and the length of YZ. So the variable and YZ. This is what we're looking for. All right, we see that two parts make the whole, so I can say that the 4C plus 11 equals the entire 83. Subtract 11 from each side. See how I'm showing my work. Divide each side by 4. 4 goes into 7 once, and then 32. So C is 18. And then since YZ is 4C, 4 times 18 is 72. Okay? Again, I feel some factoring coming with that guy. Let's look at 23. Same drawing. And yeah, I draw it every time instead of erasing it. That's my habit. If you can do it correctly without drawing, that's fine. But if you are missing these problems, the first thing for you to, the first intervention you need to go through is to start drawing them. Okay, 23. From X to Y is 7A. From Y to Z is 5A. And then we're told the whole thing from X to Z is 6A plus 24. Again, piece plus piece equals the whole thing. So the 7A plus the 5A equals 6A plus 24. So that gives us 12A equals 6A plus 24. That's 6A equals 24, or A is 4. That's one of the questions. I found my variable. But the second piece is to find YZ. So 5 times 4 is 20. Now you're going to find in geometry, a lot of the times, you're going to have questions in an exercise that build on the previous answer. So if I had missed A, I would have missed the rest of the problem. Or I could have gotten A right and made a mistake up here and then just missed a portion of the problem. But the earlier you miss a problem, the more points you're going to lose. So be very, very careful as you journey through with these. Let's look at some examples in this area, which I think you're going to find very easy. Determine whether each pair of segments is congruent, and that's the pair that they've listed for you. So are JK and HL congruent? In other words, are they the same shape and size? Do they have the same measure? JK is 4. HL is 4. So for 27, yes, they are congruent. They have the same measure. Let's look over here at 29. EH, which is 0.4500 centimeters, and FG, which is 0.5 centimeters, Are they congruent? No, they are not. They do not have the same measure, so they're not the same shape and size. So we do not have congruency here. Okay? I think that's pretty self-explanatory for honors students. So why don't we move on? Like I said, I feel a factoring problem coming. All right, and I believe here's my problem. Now, I will assign you a lot of the challenge problems throughout the year like I have here. I want us to look at 39. This one, please, honor students, do not allow the word challenge to make you decide, I can't do that. If you couldn't do it, if you couldn't make a healthy attempt and learn something from this, then you wouldn't be in the honors class to begin with. So tackle those challenge problems head on. Don't sell yourself short. I expect you to try the challenge problems, and if you don't get it right, I expect you to be able to show me on your paper what you tried and where it didn't work out for you. But just a blank sheet of paper, and I didn't know how to do it. At your age and at your brain function, you don't need to be doing that. You need to have some work down there and show what you are thinking and making mistakes. That's great. You've eliminated that this didn't work. Now try something else. Trying something over and over is not wrong and bad. It's very good. It shows that you stick with something and that you've got determination, and that's what we want you to develop. So we don't shy away from 39 because it's a challenge problem. We're going to read it and we're going to go ahead head on. Point K is between J and L. So you know what I'm going to do. I'm going to draw a picture. And I'm not going to be worried about being on scale. I don't know where K falls in here. So I just got to put him in there somewhere. From J to K is x squared minus 4x. From K to L is 3x minus 2. JL, this whole segment then, is 28 units long. Write and solve an equation to find the lengths of JK and KL. So in other words, we want to find and come up with the lengths of the two smaller pieces. All right, so I'm going to have that JK plus KL equals JL. We have betweenness. JK is x squared minus 4x plus 3x minus 2 equals 28. Now, I hope your Algebra 2 is kicking in. When you see that x squared that's going nowhere, I want you to be thinking right now, oh, this is a quadratic. And if it's a quadratic, if I can factor, that is wonderful. If it doesn't factor, I want you to remember your quadratic formula. Okay, we're going to remember all the things that we had in Algebra 2 because we're going to see a lot of them. All right, let's see what happens here. We may not need it. We don't know. Let's see what happens. So I'm going to combine my x's. So I'm going to have x squared minus x minus 2 equals 28. Since I have a quadratic and it's not falling out, that means I have to get a 0 on one side of the equation. So let's subtract 28 from each side of the equation. And let's see if this factors. I believe it's going to. X minus 6, x plus 5. So that means, excuse me, that means that my x could be 6 or my x could be negative 5. Now in algebra, that's where we would stop. But you can't stop there in geometry. You have to take each of these particular answers or roots and plug them into the values to make sure that neither one will yield a negative measure. So we don't toss out the negative 5 immediately just because it's negative. Okay, the 6 could give us a negative measure. We've got to check both of these to see if I get a negative measure. So let's look at what happens with JK. All right, with JK, I'm going to plug in 6. 6 squared minus 4 times 6. 36 minus 24 is 12. Okay, and then let's plug in for KL. Let's plug in 6. 18 minus 2 is 16. And 12 and 16 do add up to 28. So we know 6 is okay. So one of our answers is 6. Now let's see if negative 5 works for JK. Negative 5 squared minus 4 times negative 5. 25 plus 20 is 45. So far negative 5 is okay. Let's see what happens when we put negative 5 in KL. That gives us a negative measure. So that means negative 5 is rejected. Again, I'm not rejecting the negative 5 because it is negative. I'm rejecting the negative 5 because when I plugged it in, I got a negative measure. And we don't have negative measures. Don't forget, positive answers can yield negative measures as well. So the fact that 6 worked is great, and 6 worked. But 6 could have, in another problem, given us a negative measure. So be real careful with problems like that. All right, as I look at this last page, I don't see anything here that I really want to discuss with you. Let's review a little bit right through here and see if we're still doing okay. What are 2 other names for line AB? Line AB is going through that plane, isn't it? We can call line AB little m, or we could call it line BA. Both of those are great. Another name for plane P. Plane P is my flat surface, and I can name plane P with 3 non-collinear points. So I could say CBD. I could say plane CDF. There are other choices. Well, those may be the only choices. Okay. Name the intersection of plane P and line AB. We've got AB going through the plane, piercing through the plane. There's that side view that I showed you in the last lesson. And where that line is going through is at B. Here's A down here. Okay, so the intersection is point B. Name 3 collinear points, 3 in the same line. That's going to be point C, point B, point F. And name 2 points that are not coplanar. Well, it looks to me like A is the only one they have hanging off the plane there. So A and any point that's on the plane. Let's just use F because I haven't used him much. So I'll just say A and F are not on the same flat surface. Okay? All right. Now, as you look at the assignment that I have made on this section, remember, any questions, you may email me. The email is in the Google Classroom on the first message you had. You may also leave a comment because I'll be checking this all through the summer. So any questions on section 1 and 2, we need to have all those cleared up before you start section 3 coming up next, okay? Thanks a lot. See you later.